Hi everyone, welcome back. So this is video number 5 looking at diagnostics for regression models. So the first 4 videos we looked at normality of residuals, the linearity between IVs and the DV, multicollinearity and homoscedasticity. So we looked at those assumptions for a particular multiple regression model. In this video, I'm going to focus on independence of error terms, what's also referred to as no autocorrelation of residuals. Okay, before I do that, I'll just recap quickly what we've been looking at. I've been working with the MT cars dataset, so that's kind of a small dataset, 32 models of car and various information about them, such as MPG, weight, things like that. And I used stats model to fit a really basic multiple regression model where we looked at weight and displacement as predictors of miles per gallon. What we found was that weight was a significant predictor of miles per gallon, and it was negatively related to MPG. So the heavier a car, the lower the miles per gallon, which seems to intuitively make sense. We conducted a number of other diagnostic tests of assumptions, and so that's as far as we're up to now. So what I'm going to do here is look at assessing this assumption of independence of errors. So assessing independence of residuals isn't easily achieved. It's possible to verify this using visualizations if there's a clear pattern to the error terms. They may follow some sort of relationship like our independent variables in the regression model, where the residuals appear to have, so we saw kind of when we looked at the residual sort of the homoscedasticity plot, we saw the residuals here appear to have positive deviations at low values, negative deviations at the middle of the scale, and then positive deviations again at higher values of the independent variable. So that something like that might be an indication that we don't have independence of these of the kind of residual terms. But a residual plot showing kind of like a zigzagging pattern along the scale would suggest that the errors, the residuals, may be independent. So we can plot it and see what it looks like to give ourselves an idea, and we can also conduct a statistical test to assess the independence of error terms. And one we can use is the Durbin-Watson test. And if this test returns a value between 1.5 and 2.5, then those are kind of the cutoff points where we usually assume it's safe to assume independence of error terms of residuals. Okay, so we'll create a line plot to see what kind of the terms look like, and we'll also conduct the Durbin-Watson here. So I'm basically going to just use matplotlib. I'm going to use the dot plot function, like the basic function. It gives us a line plot, really. It's going to give us a zigzagging kind of, and we're doing it on the residuals. So we're taking our results object, dot resid. Remember, results was the object. It saved the results of our regression model, and we're just using dot resid, so we're looking at only at the residuals. So if I run that, you can see a real basic plot, but we seem to have this kind of zigzagging pattern going on. So this might suggest that error terms are independent, but as I said, it's kind of not an easy one. It's not a straightforward one to assess. As I said when we talked about independence for ANOVA models, a lot of the time it comes down to good research design to start with. Okay, so having done that, perhaps we could look at a statistical test, so the Durbin-Watson test, and we can perform Durbin-Watson using stats models. There's a stats models Durbin-Watson method, so I'm going to import that. So from statsmodels.stats.statTools, import Durbin-Watson, and then having imported that method, I'm just going to pass the residuals from our regression model results to it. So if we run that, what we see is we get a Durbin-Watson test statistic of 1.28 if we round that to 2 decimal places. So the value of Durbin-Watson here is approximately 1.28, and that is outside the range of values from 1.5 to 2.5, those thresholds for this test. So here we should conclude that it's not safe to assume independence of errors, and autocorrelation of residuals may be a problem for our regression model, although it didn't appear like it was based on the kind of the plot we used. So again, this is, it's I'll say it again. It's not an easy one to assess. Here visually we thought, oh yeah, it might be okay, but then we looked at Durbin-Watson, and it suggests it's possibly not safe to assume independence of residuals. But we also have to keep in mind this kind of caveat that I often mention, that these types of statistical tests of assumptions have their limitations. Okay, so that's it for independence of error terms. Okay, the next video 6 on regression diagnostics, will be the last one I'm going to do on that particular subject, and we'll look at influence statistics. Okay, hopefully this was helpful, and thank you for listening.